All right, this is part 3 of the Polygon test review. So let's get started with question number 32. And we are finding the area and perimeter of a trapezoid, and it does look like it is an isosceles trapezoid. So let's go ahead and do perimeter first, simply because that is easier and quicker. So remember, perimeter means we're adding. So let's go ahead and do that. So perimeter for this isosceles trapezoid is going to be 4.9 plus 3.9 plus 4.9 plus 10.9. All right, so let's go ahead and do that in our calculator. 4.9 plus 3.9 plus 4.9 plus 10.9. And it looks like we get 24.6. Okay, so perimeter for this trapezoid is going to be 24.6 inches. Don't forget units. And then next we're going to find the area. And remember, the area for a trapezoid is going to be base 1 plus base 2 over 2 multiplied by the height. So basically the mid-segment times the height. So in this case, base 1 is 10.9 and base 2 is 3.9 and the height is 3.4. And remember, it doesn't matter if which one's base 1, which one's base 2. I can flip that shape on its head and it's still the same shape. And so I just picked these two the way they are. Run them through our calculator. So control divide gives us our fraction. We get 10.9 plus, we get 10.9 plus 3.9 over 2 times 3.4. Okay, and that gives us 25.16. And that's going to be inches squared. Remember, area is inches squared or units squared, and perimeter is just going to be whatever units we have. All right, number 33 is a right trapezoid. First, let's find the perimeter. We have 0.6 plus 2.4 plus 2 plus 2. And you can see that, yes, two sides are congruent, but they are not opposite sides. So it is not an isosceles trapezoid. It's only isosceles if opposite sides that are not parallel are congruent. That's what makes it isosceles trapezoid. All right, so we are going to have 0.6 plus 2.4 plus 2 plus 2, and that gives us 7. And this one, the unit is miles. All right. And then let's go ahead and find the area. Again, area for a trapezoid is 1/2. Oh, sorry, let's do it the long way. Full fraction. Base 1 plus base 2 over 2 times the height. And so in this case, we got base 1 is 0.6, and base 2 is 2, and the height is 2. And so the height we're going to use is the side length between the two parallel sides that is perpendicular to the parallel sides. Let's fill in our formula. List formula substitution over time. 0.6 plus 2 over 2 times 2. All right, so control divide gives us our fraction bar. 0.6 plus 2 divided by 2 times 2. And that's going to give you 2.6. Okay. And remember, it's miles squared, not just miles. All right. Okay, moving right along, we are going to move an octagon. And it's an octagon because it has 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 sides. And we're going to find the area and perimeter. So let's find the perimeter first because we need the perimeter in order to find the area anyway. For the perimeter, it's a regular octagon, so we're just going to multiply the side length. And in this case, side length is 7.7 units of whatever units they are. They don't give us a unit. And so it's going to be 8 times 7.7. So let's see what that is. That comes out to 61.6. Okay, so let's go and write that in. All right. And then remember the formula for area of a regular polygon is 1/2 times the apothem times the perimeter. And we have an apothem on this one of 9.2. So we're just going to, and we found out our perimeter was 61.6. So let's just plug these into our formula. Area is equal to 1/2 times apothem of 9.2 times the perimeter of 61.6. Let's go ahead and type that into the calculator. Okay, control divide gives us our fractions. 1/2 times 9.2 times 61.6. Enter. And that gives us 283.36. All right. So the area of this regular octagon is 283.36 units squared, whatever the units are. They didn't give us units, so you don't have to give me units if they don't give you units. All right, number 35, we have a regular pentagon with a side length of 16 and an apothem of 11. So first we need to find the perimeter. Now there's 5 sides times 16 for the side length. So 5 times 16 is going to be 80. So the perimeter is 80. And then we're going to run those numbers through our formula for area of a regular polygon, which is area is equal to 1/2 times the apothem of 11 times 80. And we're going to go ahead and run that to the calculator. So control divide for your fraction times 11 times 80. and you get 440. Alrighty. Okay, so number 36, we have a regular hexagon with a side length of 6 and a radius of 10. So this one doesn't give us the apothem. We're going to have to find it. So if the side length is 6 and it has 6 sides, the perimeter is going to be 6 times 6. So the perimeter is going to be 36. That's going to be easy enough. And in this case, they gave us centimeters as our unit. So it's going to be 36 centimeters. Alright, so now we need to find out what the apothem is. We're going to have to use Pythagorean theorem. Remember, the apothem goes down to the midpoint of the side. So that tells me that this portion here is 3 centimeters. So we're going to draw a little right triangle with a hypotenuse of 10 and a short leg of 3 and an unknown leg of x. And so that's going to give me, if I use a squared plus b squared equals c squared, I'm going to have 3 squared plus x squared equals 10 squared. 3 squared is 9. My unknown is still x squared. 10 squared is 100. Subtract the 9 from both sides. We get x squared equals 91. Take the square root. And let's see, x is approximately 9.54. So 9.54. So let's add that data up here. A is about 9.54. So now we're going to run that information through our formula for area so that we can get the approximate area of this hexagon. Okay, so area of a regular polygon again is 1/2 apothem times perimeter. So we have 1/2 times 9.54 times 36. Now, if we want to be really technically accurate, we can use square root of 91 as our apothem so that we can be as accurate as possible. Let's see what the difference is. So we get 1/2 times 9.54 times 36, 171.72. Let's see what the difference is. Control divide. 1/2 times square root 91 times 36. It's a little bit different. It comes out about 1/100th of a, about 1/100th. So not very different. We're going to go ahead and leave it as the 171.72 because we're using the rounded number. Though technically 171.71 would be closer to accurate. So it's 171.72. 171.72 centimeters squared. I would have both answers written on the key, so no worries if you decide to be the more accurate person. I'm not going to count it wrong if you're that close. Alright, so on number 37, they give us the apothem and the radius, but they do not give us the side length of this regular hexagon. So we're going to need to go ahead and use Pythagorean theorem and work backwards to get all the way through this problem. So let's do this. Okay, so we have a side length of 8.2 and a hypotenuse of 12 and an unknown side length. All right, so a squared plus b squared equals c squared. So we get 8.2 squared plus your unknown squared is equal to 12 squared. So 8.2 squared is 67.24 plus x squared equals 144. Okay, so then we'll subtract 67.24 from both sides. So we have 144 minus 67.24, 76. So x squared equals 76.76. And we're going to take the square root. And x is approximately the square root of the answer. Let's go with 8.76 because it's 8.761. And around to the nearest hundredth. 76. So in this case, half of the side length is about 8.76. So we're going to need to multiply that by 2. Let's go ahead and hit times 2. And we're going to get 17.52. So that's going to be what we're going to use as our side length. 17.52. And it is a regular hexagon. So we're going to multiply that by 6 in order to get our perimeter. And we get 105.14. So my perimeter is 105.54. Okay. All right, so then using an apothem of 8.2, we can run this through our formula. Area equals 1/2 apothem times perimeter. So area is equal to 1/2 times 8.2 times 105.54. Okay, so times 8.2 divided by 2, and we get 431.06. 431.06. And there's no units given, so there's no units used. Okay, so we have numbers 38 and 39. They're telling us to work backwards from the area to find the missing side. So for number 38, we have a trapezoid with an area of 79.2 kilometers squared. They give us one base and the height and tell us to find the second base. So we have the area is equal to 79.2. Base 1 is 5.9. Base 2 is unknown. And our height is 9. All right, so we're going to rewrite our formula. Area is equal to base 1 plus base 2 over 2 times the height. All right, so we get area is equal to base 1, which is 5.9, plus unknown over 2 times the height, which is 9. And we could technically get rid of both the 9 and the 2 in one step, but to prevent confusion, I'm going to go ahead and do those in 2 separate steps. So I'm going to go ahead and get rid of the 9 first. So we have 5.9 plus x over 2. And I didn't substitute in the area. Sorry, guys. is 79.2. Right, and so we're going to divide this whole thing by 9 on both sides. Right, so I'm going to take 79.2 divided by 9, and that gives me 8.8. So now I have 8.8 is equal to 5.9 plus x over 2. I still can't do anything with that x because it's on the top of a fraction bar. It's in the numerator. The fraction bar acts as one of our grouping symbols, so we can't do anything with the x yet. So we have divided by 2, so to undo division, we're going to multiply times 2. So we're going to multiply times 2, and that's 17.6. Now, if you were curious as to how we could get that done in one step, take 79.2 and multiply it by the fraction of 2 over 9. We get the same answer. So it's multiplying by the reciprocals. So it's 17.6. It's equal to 5.9 plus x. And then we're just going to subtract 5.9 from both sides. And that tells me that x is equal to 11.7. And the units are going to be kilometers. Don't forget your units, ever. Right, number 39 is a square, has an area of 8.4 feet. 8.4 feet squared. And it wants us to find the side length. We know that the area of a square is just side squared. So if we have 8.4 is equal to side squared, we're trying to find the side, we're just going to take the square root of 8.4. And so side will approximately be, let's find out, what's the square root of 8.4? 2.89828. So we're going to round that to 2.90. Now, I know that sounds like I'm actually rounding to 2 decimal places, or 1 decimal place, because it sounds like 2.9. That's why we have the 0. Remember, it's 2 decimal places. So we need that 90, because we are actually rounding to that decimal place. We're rounding the 9 up, which also rounds the 8 up. So you must have that 0. If you put 2.9, it is wrong. 2.90. I said 2 decimal places. I want 2 decimal places. All right, guys. So finally, numbers 40 through 43. These are the last ones on the page. They want us to find the area and perimeter of all 4 of these figures here. And they are all composite figures. So that means we're going to need to break them down into smaller figures to work with them. So let's look at number 40. Now they did some breaking down for us. We can work with this. So it looks like we have all the side lengths except one given to us, and that's this side length here. We can find that one using Pythagorean theorem. So we see with what they've given us here that this bit right here is going to be 6 inches. So that tells me that this part here must be 4, because the whole thing is 10. So if that's 4, then this is 4. So let's go ahead and draw our triangle so we can have a bit of it. So that's 4. And we're looking for the hypotenuse. Now, what is the other leg going to be? So our full bottom length here is going to be 15. Now, we are trying to find out what a portion of it is, this small portion here. We know, based on what we have, that there's a 7-inch portion and a 5-inch portion. 7 plus 5 is 12. So that means the part I have highlighted in green here is 12 inches, and that means the remainder is 3 inches. So if we have a right triangle with legs of 3 and 4, that tells me the hypotenuse is 5. That's a Pythagorean triple, and that you should know that by default. That's something you should have memorized. However, should you not have that memorized, we always know that a squared plus b squared is equal to c squared. So therefore 3 squared plus 4 squared would be equal to x squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and the square root of 25 is 5, at least for distance. We don't care about the negative square roots in geometry for this portion, because we're not doing negative distances, so don't worry about that. So this side length is 5. So now we're going to add all those numbers together, because we are looking at perimeter. So let's do the perimeter first. So we're going to have 5, the side length we just found, plus 7, which is right there, plus 6, there, plus 5 from here, plus 10 over here, that's 15. All right, let's go ahead and add those up. 5 plus 7 plus 6 plus 5 plus 10 plus 15. That gives me 48. So the perimeter on number 40 is 48 inches. And now we need to find the area, which is going to take just a little bit longer, but that's okay. Okay, so let's find the area of that triangle. That area is 1/2 base times height. And remember, it was a 3, 4, 5 triangle. So the base is, the base was 3 and the height was 4. All right. So that's 1/2, 3 times 4. 3 times 4 is 12. Half of 12 is 6. So the area of the triangle is 6 inches squared. That's one of our areas. Our other two areas are going to be fairly simple because they're both rectangles. This rectangle here is going to have a length of 12 and a width of 4. So 12 times 4, that's 48 inches squared. And the smaller rectangle, okay, with a length of 5 and a width of 6. 5 times 6 is 30 inches squared. And now we're just going to add all three numbers together. So we're going to have 6 plus 48 plus 30. And that gives us 84. So it's 84 inches squared. All right, number 41. We have most of our side lengths. We need to logic out one of them. So we have a side length here of 6 and one here of 4 to add up to this bottom side length of 10. And label that 10. And so let's go ahead and do the perimeter. So we have 4 plus 4 plus 6 plus 6 plus 2 plus 6 plus 10 plus 10. Okay. So we have 4, 4, plus 6, plus 6, plus 2, plus 6, plus 10, plus 10. Okay, that one's 48 as well. 10, 20, 30, 48, yep. 48. And those ones are centimeters. All right, and then let's go ahead and do the area. This one's going to require a little more breaking down of the figure, a little more decomposition, but not too much. So let's just sketch a little bit of a line here, make our triangle. Now we have a 2 centimeter one that's given to us. There's 6 centimeters on this side right here and 10 right here, or 4 right there. So the whole side length is 10. 2 is given to us, so this part that I just sketched in would be 8. So that means we have an 8 by 6 with a hypotenuse of 10 right triangle there. And then we can sketch out our rectangles that we would have. So let's go ahead and sketch that line. So this is going to be rectangle 1, rectangle 2. So the area of rectangle 1, length times width. And it looks like that's going to be a square because I have a 6 for length and a 6 for width. So 6 times 6 equals 36. And then for the area of the rectangle, we have a length of 10 and a width of 4. 10 times 4 is, of course, 40. And then the triangle is 1/2 base times height. Base is 6. Height is 8. Okay, 6 times 8 is 48. And divide that by 2 is 24. Right, so our area for this figure is going to be 24 plus 36 plus 40. And we get 100. 100 centimeters squared. All right, and we're almost done. 2 more. Alright, so number 42, we are missing a side length because we can see that this whole thing right here says 15, and it shows me 3 of those are divided evenly. So those each are going to be 5. So I'm not actually worried about these ones right here. Those are each 5. What side length I'm actually worried about here is this slant length there. Let's say the hypotenuse of a right triangle. So let's make it the hypotenuse of a right triangle. We can see that the shorter side up here, I'm going to highlight. That's 30 millimeters. So if that's 30 millimeters, then what's remaining on the bottom of the 40 millimeter side is 10 millimeters. So that means we have a side length of 15 and a leg of 10, and we're looking for the hypotenuse. So with our Pythagorean theorem, we're going to have 15 squared plus 10 squared equals x squared. 15 squared is 225 plus 10 squared, which is 100, equals our unknown value squared, 325. X squared, take the square root. Pretty sure that's not actually a perfect square. 18.0278. Let's go with 18.03. It's mostly for additive purposes. All right, so let's go ahead and find the perimeter of this shape, this polygon. It's going to be 15, because it's 5 plus 5 plus 5, plus 20, plus 40, plus 30, plus 1803. So let's go with 18.03 plus 15 plus 30 plus 40. Okay. And 2 20s. 20 plus 20. That's 143.03. And you might wonder why I said 2 20s. Well, that's because I've got this one right here and this one right there. So it's 143.03. And that's millimeters. Oops. And then now let's find the area. So to do that, we're going to have a couple little breakdowns. So let's break it right here. So we had 30 minus 20. So this is another 10. By 15. So let's do the area of the triangle. It's 10 by 15. So the area of the triangle is 1/2 times 10 times 15. And then area of triangle 1, or rectangle 1, is just 10 times 15. Area of triangle 2 and 3, because they're the same, is going to be 5 times 20. Area of 3 is also 5 times 20. This is 150. This is 100, 100. Half of 150 is 75. So okay. So now we're going to add those numbers together. Okay, that's 425. And we're in millimeters, so 425 millimeters squared. Okay, one more, and then we'll be done with this. Okay, so let's do this last problem here real quick. So first I'm going to sketch in a little line here. Alright, so let's label our side lengths. So this side length right here is 6. So this one is also 6. So let's label that one 6 meters. And then we have a side length right here and here that match. So this one will be 3 meters. And then finally, we see that we have the bottom side is 15 in total, but there's 7 here and 5 here. So that tells me that the top here is going to be 3, because 7 plus 5 is 12, 15 minus 12 is 3. So we're going to go ahead and do the perimeter first. So perimeter is 3 plus 7 plus 6 plus 3 plus 6 plus 5 plus 3 plus 15. Okay, and if we run that through our calculator, which I already have, looks like we've got 46. So our perimeter is 46 meters. Alright, and now we're going to do our area. Remember that rectangle 1 is rectangle 2. So the area of rectangle 1 is going to be 3 times 6, which is 18. And the area of rectangle 2 is going to be 15 times 3, which is 45. And we can add those together. Neatly. Right, 8 plus 3 is 13. Carry the 1, 4, 5, 6. 63. So 63 meters squared. And that's it for this review. So make sure you go over it and thoroughly make sure you filled out your whole review if you want your extra credit. And if you haven't checked out videos 1 and part 2, make sure you do so at the very least you can check your work. I'll see you on Monday. Have a great weekend.